Hi, welcome to this video. We're talking about 5G as an enabling technology for building cities resistant to natural disasters. So what is 5G? Well, 5G is the next generation mobile network that can support upload and download speeds of 20 gigabytes per second. It also enables to support massive MIMO, which is multiple input, multiple output. It also has a wider access to frequency spectrum, even the unlicensed ones, and it can support networks as low as 600 MHz. And lastly, it can support high-speed device-to-device connection, making mobile ad hoc network more reliable than ever. With this, it is able to support beamforming, full duplex, cognitive radio, and ultra-band. These two applications may not be natural disaster related, but it does show the weakness of current mobile technology. First of all is SafeCity, which is a crime reporting and updating application that allows users to contact the police immediately about whenever there's a crime, and as well as updating the user base on safety levels on certain parts of the city, roads, or wherever. Emergency, on the other hand, it's an emergency application, obviously, that allows users to contact the nearest professional, such as a surgeon, specialist, doctors, nurse, and so on. Both of these applications rely heavily on the location-based systems, such as GPS and IPS addressing, because, well, they are safety and health-related apps, so it has to be quick. Even though GPS actually doesn't need internet connection, but these are important moments and time sensitive. So when the base station is down, these two applications becomes useless. On the other hand, Twilight is something actually very interesting and is actually related to natural disaster use. It is an open source Android application to be used in disaster time. The concept is that it allows tweets and messages to be sent out, but how, you wonder? Well, it's not instantaneous like using the internet. Instead, whatever you type or tweet, it will be stored locally and then searches devices that has the same app or same function and send it to the other phone. So both phones will be trading each other's messages, and whoever reaches to internet first will send out both of your tweets. But there's a downside. We're using Bluetooth technology here, so you have to almost be in person with the other person to send or exchange your messages. Secondly, another downside is the intervals of searching and scanning. It takes a while and very slow, so maybe even if you meet someone, the message may not be sent due to the interval. But why are we using Bluetooth and not Wi-Fi or any other form of mobile network? Is because Bluetooth saves power. So what can 5G solve? Well, first of all, it can perform position locating. It instantly just solves SafeCity as well as emergency. Secondly, it's power efficient. Well, at least more power efficient than 4G. So if we can lose some power, sacrifice some energy, we definitely should use 5G network. Lastly, it is a lot faster. But I gotta address one downside to 5G. It can actually be an advantage. First of all, 5G can use millimeter waves. This frequency range, the reach is not as good as 4G. So it will not be able to connect to our devices as easily. But this is easily solved by setting up smaller base stations. That way, it can reroute the network and reach to our devices. These smaller base stations can be as small and easily set up on our street lamps everywhere. This is how 5G network will look like. Example, these 3 base stations and a few more smaller stations and all the user. So first of all, I'll be explaining about beamforming. So beamforming is allowing the connections to concentrate onto a certain area of choice. Therefore, if an area was to have, let's say, more users, they could just do so, concentrating on the area which has more users. In a natural disaster situation, if one tower is down while others are still up, they can concentrate it towards that area which have got no internet. Next is cognitive radio. This one is a really interesting piece of technology. Why? Well, it can scan for network in different frequency ranges and spectrum and detect whether if it's available. This is because it has spectrum sensing, spectrum management, spectrum sharing ability. Also, it is a smart device where it can dynamically and autonomously adjust its settings and protocols to establish certain networks. It is actually currently used for locating survivors, but with 5G, because it can support a wider range of frequency, 5G can fully utilize the benefit of cognitive radio. In this situation, example, as you can see, rescuers can definitely use this to identify available network and then try to connect with them. This is also because available network can indicate that there are survivors nearby. And with the next technology I'm going to explain, position locating can even be so much more accurate. Next is ultra-wideband. Ultra-wideband is a high bandwidth that covers a lot of range in the spectrum whilst being low energy. It is used in many different precise positioning applications such as in the military to detect various items as well as soldiers, mining and so on. First of all, one of the many basic ways that ultra-wideband detects position is angle of arrival. It will send out a signal and the object will detect which angle did it receive from. This allows users to know which direction the object is at. Secondly, it's time of arrival, which sends out the signal, and the time of arrival that the signal will receive can determine how far the object is. Another form is time difference of arrival, where it sends out multiple signals, and the difference in time of arrival can be used to triangulate the position of an item. And lastly, it is hybrid, adding angle of arrival to the previous method, and you got yourself a very accurate position locating technology. Another good thing about ultra-wideband is that it does not require line of sight, which means it doesn't need to be exposed by the target. It can penetrate through walls and objects that's blocking its way. One last thing is that ultra-wideband usually have dedicated sensors to detect the wave as well as the reflected wave emitted by the host device. But because 5G devices can detect these signals, it is possible to be used in natural disaster situations and bringing such technology to everyday users. As you can see here, if we zoom into it, a rescuer can definitely use ultra-wideband to pinpoint where the users are. Moreover, users themselves can actually use this feature so that if they are in a natural disaster condition, they can find each other, and maybe teaming up could help them survive better. The best thing about this technology is that theoretically it could implement it into just a body of a 5G enabled device. Means our future smartphones all could have these features. Here's how it might play out if we had 5G and if we use Twimite's way of solution during a natural disaster. So let's say some towers are damaged, and the towers that are not damaged can beam towards the damaged area to help boost up internet. And assuming the few of the smaller towers are not damaged, due to device-to-device capabilities as well as using CR to locate network, survivors can send each other messages and eventually either one of them will reach to an internet connection, and it's so much easier with 5G. So let's say this one phone moves towards, maybe he wants to go search for survivors and so on. These other two can definitely connect to the tower rather than finding the person itself and then sending the message to the tower and to him. So when this phone close enough reach to a internet enabled phone, it will send both messages out to the internet. But you might be thinking, well, this can be even done without having the tower. So as you can see, another example, the phones can gather together and you see, you can send messages one by one, further and further. More messages are getting gathered, and then in the end got 4 messages, and there you go, sent to the internet. Our group's proposed solution. We thought that first, network providers and government can incentivize corporate companies to install cognitive radio enabled small towers within buildings or around buildings or even like on top of buildings, so that it can increase the chances of being undamaged during natural disaster like this scenario. So when it's not damaged, alright, just by having a few CR enabled cell towers, many people within reach are able to connect to the network. This allows rescuers to easily locate them, as survivors are able to simply talk and communicate directly to the rescuer, as shown in the slide. See, especially with 5G, one device gets connected, and if it's close enough to another device, the network will spread really quickly. Well, you may think that, wow, the previous scenario was so positive and that is something that may not happen easily. So now we'll just assume the worst case scenario then. Even if all the phones were to send messages to each other and are all connected, as long as any of the edge user is not connected to internet, everyone has no benefit. So our group proposed that rescuers can use drones to scan the area for different kinds of network. Using CR, you should not only able to scan, but scan for available spectrums and networks. You should be able to also adapt and quickly connect them, as shown in slides. Also, because 5G has faster connection and a much lower latency, these drones can also be used to hover upon areas and directly live feed data, live feed maps, or even recordings of a higher view of the disaster area to allow them to have more information about where they are going to. And obviously, them on the floor, on the ground, definitely be using ultra wideband to precisely locate the survivors on top of the drone. Last but not least is the challenges of implementing 5G. First of all, its cost. Is it worth it to build so many cognitive radio enabled towers or small towers to improve 5G connectivity? Is it worth it for the government to invest all these different technology for an emergency that may not even happen? Is there any benefit for a company to even hold or store any emergency network equipment that's so expensive to not just keep but maintain, as networking infrastructure can cost a lot? Next is standardization. So many technology are unlocked by the capabilities of 5G network. Therefore, are they standardized to all work with each other? Will there be different states or countries, different technology that cannot be compatible with ours? Or will it be restricted? Will it be unified for all 5G network? Next is adoptability. Expert expects that 5G can be released and would be broadly used by everyone around 2020 or 2025. But for our solutions and for 5G to strive, 5G devices must be widely adopted and become a normal, common thing, or else there are a mix of 4Gs and 5Gs devices out there, and 4G devices are going to miss out on the benefits that we just explained in this video. Security. There's so much innovation and so much that you can do with 5G, so open and so flexible, which will lead to a lot of security issues. As will there be a standardized software and algorithm to support such technology? So much open connection capability are prone to being hacked. But if we have too high of a security, will we still have the flexibility to connect to other networks in times of an emergency? Or will it be a difficult process? So, what's your opinion about 5G? What do you think of our proposed solution? Give a comment down below.